Insert two numbers between 3 and 81 so that the resulting sequence is a GP. Now this is a very simple question because you just have to insert two numbers and between 3 and 3 raised to power 4. So we obviously know that these numbers are going to be these, right? We can do this question while sleeping, but as this is a concept that we need to follow of geometric progression, so we will write this like this: 3 G1 G2 81. Okay, let the two numbers be G1 and G2. So this is the fourth number, 81, right? So what is the fourth number? A r raised to power 3. So what is A? A is 3. R raised to power 3 is equal to 81. So what is R raised to power 3? It is 81 by 3, which is equal to 3 raised to power 3, right? That gives me R equal to 3. Okay. Now if R is equal to 3, what will be G1? I'll have to multiply this 3 with this R to get G1. So G1 is equal to 3 into R, which is 3. So 3 squared. What is G2? G2 is 3 squared into 3. That is 3 cubed. So this is the answer. I won't spend any more time on this question. Okay, so you have to write the rest of the things yourself. Find the value of n so that this may be the geometric mean between a and b. So what is given is that a raised to power n plus 1 plus b raised to power n plus 1 divided by a raised to power n plus b raised to power n is equal to square root of ab. This is the geometric mean, right? So what I can do in this question is I will cross multiply. So this is a raised to power n plus 1 plus b raised to power n plus 1 equals a raised to power n plus b raised to power n into root ab is nothing but a raised to power 1 by 2 into b raised to power 1 by 2, if we can write them separately. Okay, so if I multiply this here, so it will become a raised to power n plus 1 by 2 into b raised to power 1 by 2 plus b raised to power n plus 1 by 2 into a raised to power 1 by 2. This will be the multiplication, and on the left hand side I have a raised to power n plus 1 plus b raised to power n plus 1. Give me a moment, please. Okay, now what I am doing is I am taking these two terms on one side and rest of the terms on the other side just to do the manipulation. So a raised to power n plus 1 minus a raised to power n plus half into b raised to power half is equal to b raised to power n plus half into a raised to power 1 by 2 minus b raised to power n plus 1. Okay, now I'll try to take some things that can be taken as common. Okay, now this term you have to understand, n plus 1 by 2 is nothing but 2n plus 1 by 2. N plus 1 by 2 I can write as 2n plus 1 by 2, right? So let me do that here and here. 2n plus 1 by 2, and this is also 2n plus 1 by 2. What I'll do here is I will take a raised to power 2n plus 1 outside, right? A raised to power, if I take a raised to power I think that would have been more appropriate, n plus 1 by 2, because then I could have taken a raised to power n plus 1 by 2 outside, right? Let me write it once again like that, then I'll show what I'm thinking. If I write this as n plus 1 by 2 and n plus 1 by 2. Now let me see that. And this is the calculation part, right? Again, I have to make some effort like you do. So if I take a raised to power n plus half outside, now this is n plus half and this is n plus 1. If I take n plus half out of this, I'll have a raised to power 1 by 2 inside from this term, right? Because n I have taken out. Out of this one, half I have taken outside. So I'll be left with a raised to power half. And this I have completely taken outside. So inside I'll have b raised to power half only. Okay. And from the right hand side also we can do the same. If I take b raised to power n plus half outside, this will be a raised to power half minus b raised to power half. And a and b are two different numbers, so we can cancel these out. And these powers are same, right? So I can write it like this: a by b raised to power n plus 1 by 2. And obviously this cannot be equal to 0. Okay, so the b cannot be equal to 0. So a plus b raised to power n plus 1 by 2 is equal to 1. And we know that a and b are two different numbers, they are not equal. So this power n plus 1 by 2 has to be equal to 0. That means n will be equal to minus 1 by 2. Okay. The calculation part that I have done here is you can do it your own way, but the result will be same. N will be equal to minus 1 by 2. Okay. We cannot have two different answers. We can have two different ways of calculating it. Even if you write this term as 2n plus 1 by 2, even then we can solve this question, but I found this simpler, so I did it like this. Now I leave it to you how you do your calculations. The sum of two numbers is 6 times their geometric means. What does that mean? Sum of two numbers, let those numbers be a and b. So sum of those two numbers is 6 times their geometric mean. So sum of these two numbers is a plus b and it is 6 times their geometric mean. Show that the numbers are in this ratio. So I have got a plus b equals 6 square root of ab. If I can obtain a minus b, I will be able to find this ratio a is to b. I'll tell you how. There is a very simple method of doing that. So if I know a plus b is equal to this, so what will be a plus b whole squared? It will be equal to 36ab. And what is a minus b whole squared? It is nothing but a squared plus b squared minus 2ab. So you can write it as a squared plus b squared plus 2ab minus 4ab, right? And what is this part? This part is this a plus b whole squared, right? So you can replace this with 36ab minus 4ab, that will give you 32ab. All right, now you have got a minus b whole squared as 32ab. Okay, now let us look at the ratios. While calculating the ratios, what I wanted to say was that if you can calculate the ratio of a plus b and a minus b, and this is some ratio, right, divided by something, then you can convert this into ratio of a is to b. How? By taking componendo and dividendo. What we do that in componendo and dividendo, there is a property of ratios, right? If x by y is equal to a by b, let us say, then by componendo and dividendo we can say x plus y divided by x minus y will be equal to a plus b divided by a minus b. And this is always true if this is true, right? You can check it yourself. If 1 by 2 is equal to, let us say, 3 by 6, then 1 plus 2 by 1 minus 2 will definitely be equal to 3 plus 6 by 3 minus 6. You can check it. This is 3, this is minus 1. So left hand side is minus 3, and this is 9, this is minus 3. So right hand side is also minus 3. So this is a very simple property known as componendo and dividendo. I am sure that you have studied it in junior classes, componendo and dividendo. If some of you haven't studied it because it was not in your syllabus, I would recommend that you Google search it and learn about this property. This is a very useful property. Okay, so now this will be equal to what? See, if A is to B is equal to, if you have to prove that A is to B is equal to 3 plus 2 root 2 by 3 minus 2 root 2, instead you can prove that A plus B by A minus B. What I am doing is I am applying componendo and dividendo, okay, is equal to sum of these, that is 6, by 3 plus 2 root 2 minus 3 minus 2 root 2. So that will give you 4 root 2 in the denominator. So even if you can prove this, this is going to be true. Okay, so let us prove this. I will divide this with this. So I'll have a plus b divided by a minus b. I'm taking the square root also, or I can take the square root later. 36 by 32. ab is cancelled. Okay, and square root. Okay, so this is 6 by, and how much is this? This is 16 into 2, so 4 can be taken outside. 6 by 4 root 2, which is this. So I have already proved. Now I just have to take componendo and dividendo, then I can say that this is also true. So I proved this by applying componendo and dividendo. If you want to do it in a lengthier way, what you can do is you can write a plus b equals 6 root ab, a minus b as this is 4 root 2, 4 root 2 root ab. Then you can add these. 2a will be a certain number, then you can find a. Similarly, you will find b. Then you take their ratio and you will find the same answer that I have found. Okay, so these are the two ways to do this problem. If a and gb, am and gm respectively of two positive numbers, let those positive numbers be small a and small b. So what is a? It is a plus b by 2. What is b? What is g? G is square root of ab. Okay, then prove that these numbers are, so these numbers can be written, this small a and small b, we have to write them in terms of capital A and capital G. How do we do that? You see, in this there are these terms a plus g and a minus g. A plus g is what? A plus b by 2 plus root ab. So if you notice, what is this? This is a plus b plus 2 root ab divided by 2, and this is root a plus root b whole squared divided by 2, right? Similarly, you will appreciate that a minus g will be equal to, this will become minus, so here in the numerator I'll have root a minus root b whole squared, and in the denominator I'll have 2, right? So a plus g and a minus g I've got. What about square root of a plus g into a minus g? It will be equal to root a plus root b whole squared by 2 into root a minus root b whole squared by 2. So square and square root. So it will be equal to root a plus root b into root a minus root b by 2 into 2. So 2 will come out. This will be this square root. This square root. And what is this? This is a root a squared minus root b squared, so a minus b by 2. And what is this a? A is a plus b by 2. Now let me check whether what is the result. A plus b by 2 plus minus a minus b by 2. So when I consider the plus sign, a plus b by 2 plus a minus b by 2, and this b will get cancelled, so it will be 2a by 2. So yes, it will be equal to a, and when I consider the negative sign, I have b there. So yes, these are the numbers. Okay, so you can think about this question in this way. Another way of doing this question can be a lengthier method, wherein you can take these equations. One is this, another is this, right? Then probably you can find value of a plus b, and then a minus b, solve them, find value of a and b separately, and those values will come out to be these. Okay, otherwise what you can simply do is you can make use of this answer that is already given to you and proceed in the way that I have done. What I have done is mathematically correct. There is nothing wrong in doing that. So it is much simpler than the conventional method. Number of bacteria in a certain culture doubles every hour. So if there were 30 bacteria present in the culture originally, so every hour it doubles. So 30, then in the next hour it will be 60, in the next it will be 120. So if you notice, the common ratio is 2. Okay, first term is 30. How many bacteria will be present at the end of second hour, fourth hour, and nth hour? Okay, so 30, we were, the number of bacteria that we had originally were 30. After 1 hour, so 30, 60. At the end of first hour, you had 60. At the end of second hour, you had 120. That means 30 you had originally, 30 into 1 at the end of first hour, 30 into 2 at the end of second hour. So this much you have obtained. The answer to this part is 60, right? So at the end of fourth hour, it will be 30 into 4. At the end of ninth hour, it will be 30 into n. This is how it is. No, there is a mistake. I am making a mistake here. So because this is getting doubled at end of every hour. So it is getting 30 into 2 here and 30 into 2 squared here. And after this it will be 240. So that will be 30 into 2 raised to power 3. Right? This was a mistake on my part. So at end of every hour it is getting multiplied by 2. Okay, the point I wanted to make was at the end of second hour it will be 2 raised to power 2. At the end of third hour it will be 30 into 2 raised to power 3. At the end of fourth hour it will be 30 into 2 raised to power 4. At the end of nth hour it will be 30 into 2 raised to power n. This is how this sequence is working. Okay, pardon my mistake. And let me write this answer also correctly. At the end of second hour it was 120, not 60. What will rupees 500 amount to in 10 years after its deposit in a bank which pays annual interest of 10% compounded annually? So you notice, if there were 100 rupees and it is being uh, interest is being paid as 10% annually. So at the end of first year you will have 110. So what is the multiplying factor? It is being multiplied with 1.1. At the end of second year you'll again multiply it with 1.1, because 10% of this will get added, so it will become 121 now. Okay, this is how the compound rate of interest works, and we have to start with 500 rupees, or the other way you can think about it is 100 into 1 plus 10 by 100. This is the rate of interest, right? And here I write time, which is in years. So if at the end of first year I'll write 1 here, so this will become 100 into 1.1. At the end of second year I'll write 2 here, it will be 100 into 1.1 squared. So this is the multiply factor. What I want to say is 500 is something that we started with, so the first term is 500. Common ratio is 1.1, and this is going to be for 10 years, so n is equal to 10. And what do we have to find? What will this amount become in 10 years? Okay, so if you have noticed, it will become 500 into 1.1 raised to power 10, right? Because at the end of first year it would have become 1.1, 500 into 1.1. At the end of second year it would have become 1.1 squared. It goes on like this, right? So this is your answer. Okay, so but if you are wondering where have I applied the geometric progression in this, let me show you. This is the first term, right? And okay, let me erase everything and show it to you once again. If first term is 500, what is happening to it is 500 into 1.1. It will be the amount at the end of first year. At the end of first year. At the end of second year, it will become 500 into 1.1 squared. So if you see this term, and this term, it is getting multiplied with 1.1, right? How do I know that? I know it by compound interest formula or by simple logic, that it is being compounded at 10% annually. That means 100 rupees will become 110, or 1 rupee will become 1.1. This is the multiplying factor, right? If 1 rupee becomes 1.1, 5 rupee will become 5 into 1.1. This is the logic. Okay, so what I am supposed to find is, I need to find the nth term here. I don't have to find the sum of every sum of amounts at the end of every year, because if I do that, that will be much more than the actual sum. So I don't have to add these terms. I want to find the uh, term that will be the at the end of 10 years. So at the end of 1 year it is 500 into 1.1. At the end of 2 years it is 500 into 1.1 squared. At the end of 10 years it will be 500 into 1.1 raised to power 10. This is the logic. Okay, or you can say A is 500, R is 1.1, and you need to find 11th term. N should be taken as 11 here, because first term is this 500. We started with this. At the end of first year, this was it. So at the end of 11th, at the end of 10th year, there will be total 11 terms if I start with this. So I need to find the 11th term. What will be the 11th term? A r raised to power n minus 1, that is 10. So this is your answer. Okay, I have explained it in both ways. Now it is up to you how you want to understand. And I always recommend that you should do a question in multiple ways. You should be able to think about a particular question in multiple ways. That is the purpose of doing mathematics. It should open your mind to various possibilities so that you are able to do a lot of questions in physics and chemistry in different ways. And in general life also, this is very useful to think about a problem in multiple ways. If AM and GM of roots of a quadratic equation are, let the roots of this quadratic equation be A and B. Okay. And their arithmetic mean is 8, so a plus b by 2 is 8, and their geometric mean, that is root ab, is 5. So what I can say about their product, it is 25. Then obtain the quadratic equation. Now these are the roots a and b. So what is the quadratic equation? Quadratic equation in terms of the sum and product of roots can be written like this: x squared minus sum of roots into x plus product of roots equals 0. This is the way we can write the quadratic equation. This is what we studied in class 10th. So let me write x squared minus, what is sum of roots? A plus b. So a plus b by 2 is 8, so a plus b is 16. So 16x. What is product of roots? A into b, that is 25. It is equal to 0. So this is how simple this question is. So this is the end of this exercise. I hope you would have understood each and everything that I have taught here.